I'm here today to talk about effective software development. And effective means successful in producing a desired or intended result. And I think effective software development is about delivering business value. You can spend a lot of time digging into technology, but if you're not building something that moves your company forward, that's not going to go on for a long time. But it's also about removing the things that don't bring you business value. Who's familiar with the term yak shaving? A few. Okay, so yak shaving is where you find yourself doing some fiddly task that doesn't seem to have any value, but you got there because there are 10 steps that you had to do the thing you actually cared about. So, you wanted to make a code change, but then you found that there were some broken integration tests and you needed to upgrade a library, and then the build failed because of security scanning. And suddenly, the thing that should have taken 2 minutes is taking hours of your day. So I've worked in teams building APIs, building tools for engineers for a long time, and I think the main focus for those teams really is removing those fiddly steps so that product engineering teams can really concentrate on building features and products. This is a great book. If you haven't read it, I really recommend it. Accelerate talk about building high-performing technology organizations, and they deliberately couch that in terms of the impact you have on a business. So for them, high performance means you improve the profits, profitability, productivity, and market share of your business compared with your competitors. And they did some surveys, and they found some metrics. You've probably heard of the DORA metrics that are correlated with high performance as a business. They also found 24 key capabilities that tended to produce better performance on those DORA metrics. And there's a lot of information on this. It covers lots of things. The thing I find really interesting about this is it's not very much about technology. There's a lot about continuous delivery, but it's mostly around product and process, culture. There's a few about architecture, and I want to talk specifically about those. So loosely coupled architectures, microservices is a good example of that. They mean that changes in one place are unlikely to have an impact somewhere else, which allows teams to write, test, and deploy code pretty much without having to worry about the impact they have on another team. They can work independently. Empowered teams, the second architecture-related capability that Accelerate talk about, is about making your own choices about how you solve a business problem. But Accelerate actually also say it's about making your own choices in the tools that you use, the technologies that you use. And they found that that's important. And I'd characterize both these things together as autonomy. But there's a trade-off when you aim to optimize the autonomy of your software development team. And I've been an engineer. I was a Java engineer for 20 years. It's lovely when you get to choose your own technology, but for an organization, it's a problem if every team is off building things in using different technologies. So the trade-off is between autonomy and standardization. So autonomy means that you don't have to coordinate with other teams. You can release your changes on demand when they're ready, which means you have small releases, you get quick feedback, much less likely to have the release fail. And you can choose the right tools for your requirements. You don't have to try and stick a graph of data into a relational database. I've done that. It's really difficult. It was much easier to use a graph database. And autonomy does make people happier. And there's this book by Dan Pink about what motivates people, and the three things that he brings up are autonomy, mastery, and purpose. So autonomy is, do you have the freedom to decide what you're going to do and how? Mastery is about improving your skills and learning things, which I think software engineering as an industry is very, very good at that. Conferences, blog posts, videos. And purpose is about feeling that you're working towards something worthwhile. So those three things together can give you a real sense of motivation. But there are benefits to standardization as well, including have a fairly standardized tech stack. It's much less complex. Makes it much easier to operate your systems if you don't have a lot of different technologies. And I used to be responsible for operations at the Financial Times. And you don't want to have a production issue and not actually know which of several different ways of deploying things have been used for that service. It gets very difficult. It's much less risk because you don't have as many things to make sure that they're securely patched and updated. There's lower cost, normally, because you're not having multiple vendors for a particular thing. And it's just easier to move things between teams, and that would be services or people, if there is a standardization. I spent over a decade working at the Financial Times. I joined as a Java developer, and by the time I left, I had moved from product engineering into platform engineering, and I was a tech director responsible for operations. And the trade-off between autonomy and standardization was a major theme for me of the time that I spent at the FT, and for the FT at the time. And what I'm going to recommend is the idea of paving the road to find a balance between autonomy and standardization. And I'll go in more detail into what that is later. But the idea is that you pave the road to production. You make it easy for people to build, release, and operate software, while allowing people the autonomy to go off the road if there's something that they really need to do that they can't do right now. So if a team has a need for a kind of data store that you don't support, they should be able to go and start using that. So I'm going to cover 3 areas. I want to talk about how the FT got to that position. There's a bit of a history of like how you structure dev, ops, and infra. I want to talk about principles to use when building that kind of a paved road, and then the expectations for teams that go off the road. But I want to just check. So if I characterize engineering as being product engineering versus platform engineering, so products, you're building products for your customers, which of you would be working in product engineering? And platform engineering? Cool. So what I'm mostly going to try and do today is convince your product engineering people that you really ought to give up some autonomy so that platform engineering people can help you to do your job. That's going to be my aim. It might be a tough sell since the audience is overwhelmingly product engineering. I joined the FT in 2011. And at that point, we had a pretty small set of technology that we used. There was a mandatory development platform. Systems were written in Java. All systems were written in Java, deployed to Tomcat, Apache in front of it with MySQL as the database. And that was your choice. Well, there was no choice. So imagine there's a pendulum between complete free-for-all on one side and complete standardization on the other. We were definitely over at the right-hand side of that pendulum. And this is what the teams look like. It's pre-DevOps, so we had development teams. I was in a development team. We would write code, package it up, and then hand it over to an ops team, and they would deploy it to production and support it. And we had a platform team, infrastructure team that would buy servers, rack them up, and configure them. And I think this is probably pretty standard in 2011 as a setup for teams. Do people here remember this kind of setup? A few. You're probably just, I can say this, a bit older. It's a fair amount of waiting for another team to do something. So, for example, I would write my code, and it would get packaged up, and then at some point, it would make it to production. You don't need to see the detail of this. I just want to say this is the path to production, as in a release. It's an entirely manual release process. Stories were batched. There was hardly any automation. And we released to production once a month on a Saturday because we couldn't release to production without stopping the ability for editors to publish stories, and you can't really have a newspaper where you tell people they can't publish the news for a while. So once a month. And if I tried to plot autonomy against standardization at that point, highly standardized, very little autonomy. We had a really ornate build and release system that had been very configured, and pretty much every team had a box under someone's desk that was running Jenkins so they could get quick feedback for a build. So it just was really constraining. So the organization wanted to make the pain go away, and we wanted to be able to do more releases than 12 a year. And there were 3 things happening around this time, and they were all because of big changes in the industry. So first, the infrastructure team started to build a platform for provisioning, and they imaginatively called it FT Platform. And it used private cloud at first and then the cloud. The first focus was, can we get a server ready for someone to put code on more quickly? And we went from 120 days, literally took 120 days when I first joined the FT to get a server to put code on, to 15 minutes. And that's quite transformational. It means you can actually think, oh, I've got a new idea for a product, and I can now go and build it. And the second thing came as a result of infrastructure as code and automation. We basically started doing microservices, started building small services that we could deploy more frequently. And because we had that loosely coupled architecture, we could release more often. So this is from late 2021, number of releases we were doing per day at the FT. It's around 2,500, which means we sped up. In terms of number of releases, we're at 250 times as many releases as we had been doing. Again, that's quite a big change. It really changes everything about how you approach work. Rather than it being between 4 and 6 weeks for me to get feedback for a change that I had written, it was half an hour. We also had a final change, which was the move to you build it, you run it. Because if you're doing microservices, you can't really hand over the code to an operations team 10 times a day. We were releasing 10 times a day in my team. So we adopted a more DevOps mentality where we did everything. We built the code, we released it, and we supported it in production. And I think you build things differently when you're the one that's going to be woken up as a result of it breaking. We definitely moved away from one particular data store because all the developers on the team said, not convinced I'd be able to fix if things went wrong at 3 in the morning. So by now, this is what the organization looked like. We had DevOps teams and a platform. So more than infrastructure, it was really thinking in terms of we're building a platform for all these DevOps teams to deploy to production. So kind of reduced standardization to some extent, because now development teams could spin up a server and install anything they wanted on it, and spin up a VM. And we started to see people using different data stores, bringing in document stores, graph databases, and making really good use of that. So definitely provided a little bit more autonomy, reduced the standardization a bit, but there was still a problem with this, because lots of decisions were made for you. FT Platform just assumed that you had to use the platform. So it was really helpful when we were new to the cloud, because it felt a bit like training wheels. So no one really knew AWS, and the platform could make it easy for you to do stuff. But if you joined the FT and you already knew how to use AWS, you just found you couldn't do the stuff that you wanted to do because the platform had helpfully abstracted all of that away. And it was all or nothing. It was built on the expectation that you used all of it. You couldn't just take some useful tool and use it. And teams just started to choose other options. And one team building the new website decided to use Heroku. So Heroku, to deploy all of their code, didn't use the platform at all. My team started to use containers because it saved us a great amount of money in terms of hosting, because we could put multiple services on the same VM, which the platform just didn't allow for. So we'd moved towards having quite a minimal platform. So the pendulum had kind of swung right over. But you ended up with an organizational structure like this, because soon the underlying platform got thinner. There were still some things that were being done centrally, DNS, CDN, observability tooling. But every single team had a kind of mini platform team in it, because they were all taking their own decision about how to do stuff. There are some good aspects on this, but actually you're repeating a lot of work. Every team has to solve the same problems about how do you build and deploy and support stuff in production. You're wasting time there as an organization. And there are other downsides to having a free-for-all in terms of the tech that you use. The minimal platform gave teams a lot of autonomy, but there was very little standardization. And then you just end up with a huge number of different things. And this is just a small subset of the stuff we were using in production at this point. So we had Java, we had Go being used for back-end systems, we had platform teams using Python, all the front-end teams were using Node. There were people deploying to AWS on EC2. There were people using Lambdas, Heroku, Kubernetes clusters. We actually had 2 separate Kubernetes clusters that were completely different because they'd been written by different teams. So this is not a sensible way of going about building a technology department. And there were lots of different data stores. I'm a bit more relaxed about that because I think there's a good reason to use different types of data store. And with each tool and technology that you add, you increase risk, because that's another thing that could be vulnerable or that things could go wrong with. And there are higher level goals that you have as an organization. And I was a tech director by the time I left the FT, and I was responsible for operations. And honestly, I care about security. The FT does not want to be in the news for being hacked. But if every team is responsible for all of their technology, you've got to assume that every team has a deep understanding of what it means to build secure software. Cost control. If you have the freedom to spin up your own resources, I've been there as an engineer. You think, oh, I don't exactly know how to tune this. I'll just give myself plenty of resources. I'll make sure I've got plenty of memory, plenty of CPU. You do that across the organization, and you have quite a big cloud bill. And then there's the operability. You don't want things to be broken and broken for a long time because you're having to work out how this service is deployed and where the logs are and just generally trying to understand this particular team's decisions. I had a security incident at the FT where it turned out that team had decided to ship their logs somewhere different from where everyone else shipped their logs. I couldn't get access to it. That's a nightmare scenario. So you rely on all the teams understanding what needs to happen. It's not that people don't have a wish to be secure, but does everyone understand what it means? So we introduced something called the guardrails, where we defined the expectations for systems being released to production. And this was focused not on what you do as a development team, because development teams understand that. It was the things that you might not consider when you're getting something ready to go to production because you're not maybe steeped in the idea of operations and infrastructure. So building things right, keeping them safe, secure, and operable. And they started with a checklist. It's loosely in the order that you do things. And when you dug into this, you would see policies and standards that would help you decide what you needed to do. And we said to the teams, whatever you choose to do, you can go and do your own thing, but it has to comply with these guardrails. So whatever you build has to, say number 8 there, change and release logging. Whatever you build has to call into the change API and register that you made a change. We need you to have health checks and monitoring. You need to consider accessibility. But there are still issues. So it's a lot easier to write guardrails than it is to maintain them. You know, documentation constantly goes out of date, so you have to really think about how you dedicated ownership to make sure that these things stay up to date. And you have a difficulty of understanding whether every team is complying with the guardrails. How do you know that everyone's put their security scanning into their build pipelines? You don't necessarily know. In an organization that's pretty free in terms of tooling, you don't necessarily know what you have in the estate, because we definitely had cases at the Financial Times where a developer with a credit card bought some new tool, and I didn't know it even existed. So, pendulum has swung a bit. The guardrails made it easier for people to know what to do, and engineers really liked the fact there was a checklist, and they could say, yeah, I feel pretty confident that I can go to production. So that's a good thing. They removed a little bit of autonomy, but they added a bit more standardization. But what they really did was they demonstrated to all of our product engineering teams that they actually had quite a lot of infrastructure and operational work to do. They might have been ignoring some of these things that they needed to do because you can write code and get it to production really quickly, but you still need to do all of these other things around monitoring. And in the days of a mandatory platform had been done for these teams by someone else. So we started to get people saying, oh, I just would like someone else to manage some of this for me. And there was still the problem of the diverse choices of languages and platforms. Because what happens when a team has to take over a service? So I don't think people get the ownership of services right first time. Your understanding of something, your understanding of where something sits in the domain, quite often moved things between teams. Quite often wanted to do that. And there's this thing with microservices about, oh, it's fine, you know, if you move a service from a Java team to a Node team, they'll just rebuild the service in Node, it'll take a day. But the problem is you have to understand the business requirements, and often when you're asking a team to take on a service, the last thing they want to do is spend a week rewriting it and understanding it. And moving people becomes hard if everyone works differently. So you do have changes in priorities. So maybe there's new legislation, or your company has a great new idea for a product, and you need to move people around. It's a lot harder to move people if they're not just moving team. Like moving team can be enough of a disruption, but if they're having to go from Java to JavaScript and AWS to Heroku, that's a big ask for people. And I think it's good for developers to move teams. It's good for the company as well. You learn a lot more when you go and spend time with other people and you understand their processes, their technologies. But it's just friction if it's all different. And programming language is particularly painful. It's not that people can't pick up a new programming language. It's that you form communities. You have a community. You understand a particular language, and you feel part of that. You invested in it for your career. You're expecting to go and to take a new job that's in the same language. If we asked at one point quite a lot of people at the FT to move from writing back-end Java services to front-end Node services. That's not an appealing or easy move necessarily. And actually, full stack has to stop somewhere. We talk about full stack engineers, but you can't, in a team of 5 to 10 people, know everything that you need to know. So do you have a security expert? Do you have an accessibility expert? Does someone understand operations and reliability? Most engineers at the FT were T-shaped. They had a depth in one area and a little bit of knowledge on either side, but you just couldn't cover everything. And you shouldn't expect to have that duplication in every team. So product teams need help. They need to be able to focus on the important business work and be able to go to other people who understand how to configure WAF in front of their website or how to set up their first serverless project. And the problem is, the more variable the tech stack is at that top, the less an underlying platform team can do to help the product engineering teams. Trivial example is, let's say that you want to build libraries that support particular needs. The more programming languages that are being used, the more parallel work you have to do in the platform team to provide a library in all of those languages. Or if there are 5 different ways to deploy code to production, and you want to put in a call to put security scanning in, you've got to find 5 solutions for that. It's just a huge amount of extra work. So we started to build a paved road. And paving the road is about taking the path people take to production and making it easier. So you could walk along that path on the left, but once it's got tarmac down on it, you're much less likely to turn your ankle in a rabbit hole. So it's about building a set of options that work well together and that make life easy for engineering teams. So abstracting away some of the complexity that just isn't key to business value. Paved road should be fully supported, which means that upgrades, patches, security fixes are handled by the team that runs it. So it should be obviously better than building your own thing as a product engineering team. And that's somewhere that platform teams quite often get wrong. But I also think it shouldn't be mandatory. It's a very useful feedback mechanism of whether you're building something people like if they can opt not to use it. I've worked somewhere where there was a mandatory platform, and people don't necessarily listen to their customers. If you have an optional platform, you've got to build something people want, and you have to sell it to them. This is a great blog post from a former colleague of mine from quite a long time ago now, saying that if you're infrastructure operations in an organization, you should think of yourself as a service provider. You are competing with external companies. But you should be able to do better because you only have to meet the needs of one company, the company that you work in. So teams can go off-road in this situation. If they have something they need to do, they can go off-road. But it's probably going to be a bit harder work because it's not paved. They're having to hack through the undergrowth. There should always be a space for innovation. Platform teams shouldn't believe that they're the only people that could understand what could work in this area. So you need to let other teams solve problems or try something out because they've heard about it and it's great. But you should find it's harder because you've got to comply with all the guardrails. So we did want to look at changing the mindset of that platform team, though. And Sam Newman published a great blog post, which I haven't actually put a link on, but he talked about don't call it a platform team, because if you call a team a platform team, they think that their job is to build a platform. But your job isn't to build a platform. It's to reduce the cognitive load of the product engineering teams and make it faster for them to provide business value. So we renamed our team to engineering enablement, and that was everybody that provided tools or anything for engineering became part of that group. And we tried to think not in terms of building a platform, but in terms of speeding up other people. And a lot of this comes from team topologies, the idea that your platform team is there to reduce cognitive load. Team topologies talk about several different types of team. So a stream-aligned team is product engineering team. Normally, you're working on a single valuable stream of work that provides value to the business. But you do also need other teams. So a platform team should focus on allowing other teams to get on with their work with substantial autonomy. An enabling team they're experts. They're the experts in security or in operations. And they go in and share that expertise with other teams. So they might be coaching or they might be building tools to make it easy for you to use that. There is a fourth team. It's called complicated subsystem. I'm not really going to talk about that because I haven't seen it in action. The idea is that you may have a team that specializes in maintaining the machine learning model, something that's really complicated for everyone else to use. And this is the kinds of things that the engineering enablement team at the Financial Times looked after. So if you were a streamline team, you're a product engineering team, you could come to people who would have expertise there who could help you get going. So Paved Road moved us a bit more towards standardization. The central team built a set of core capabilities. But it still allowed a high level of autonomy because you could go and build your own thing if something wasn't there for you. So that's my pitch for Paving the Road. And there's a great blog post from Charity Majors. She calls it the Golden Path, which is, I think, what Netflix called it, about how to go about choosing a set of technologies and getting buy-in for that. But I just want to talk about how you decide what you would include in that kind of common set of tools that you'd expect to have provided to you as a product engineering team. And I think having some principles is useful for that. So the first thing is about building what people need, because you always have to choose what work you're going to do and what work you're not going to do. And this sounds really obvious, right? Build what people need. But my experience is platform teams have a list in their head of everything they want to build. And they've not really checked whether that's the most important thing that people need right now. You need to actually understand your customers. And when I worked in platform engineering, we basically thought of ourselves as product owners to some extent. We went out and spoke to customers and worked out what it was that they needed. So you start by making sure that what you're building has obvious value, solving a problem that people have right now. And actually, the first thing to think about is if I can buy something that solves this problem, I should do that. Because quite often, that is all that you need to do. Engineers like to solve interesting problems. Often that problem has been solved by someone else, and you should just buy it. Like, I don't know. I've been at multiple organizations where an engineer has decided to build a continuous integration tool. I don't think that's what people should be doing. There are tools out there. You need to talk to people. There's a concept of a desire path, and this is a really bad example of it. Because a desire path is where you have a park or something, and you don't pave any roads through it. You just wait until you can see where people want to walk, and then, in theory, you pave it. Or you put a fence down, you say, ha, 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 no, I'm not letting you out there. That's bad. So you don't want to be the platform team that puts a fence in. You should look at what people are doing. So at the FT, we noticed that a lot of teams were using Circle CI for build deployments, so we went and took over the relationship with the vendor. We made it available to everyone else. We migrated our CDN provider because we could see one team had needs that weren't met, and they had tried out a different CDN, and we decided that actually we should just move everybody for that standardization. Part of building something that people value is about making sure it's better for your user. Migrations are painful and constant. Like, you're always being asked to move your source control system or being asked to move something else because, oh, there's a better deal from this vendor. I think that you should be careful which ones you choose to do. But if you are going to do that kind of migration, you really ought to try and make the thing that you've got better for a team afterwards. So we had a change API at the FT that we used for logging releases, and it was a bit flaky, so we built a new version, and we said, well, you know what, it's really resilient now, it's not going to break your builds, but also we have built libraries and other components for you to plug it into any release pipeline. Even more than this, we actually sent one of our engineers to sit with a team and put the Circle CI orb into all of their build and release pipelines. So she did that for them. They didn't have to do it, and we could prove to them it was better. The next principle, I think, is about reducing the risk of people adopting the things that you build as a platform, because there is a risk of trying to use something, and you want capabilities to be owned and supported. I expect anyone that's worked in tech for a while has seen something you use, some tool, get acquired and be announced end of life, and suddenly you have to move, and it wasn't on your list of things to do, but now you have to do that. Owned means actively owned, so that there's someone you can go and ask questions if you can't make progress. And supported means there's a plan, and you're going to support this for the long term. You improve it, you patch things. If you're building tools for other teams, the worst thing you can do is get a reputation for pulling the plug, because the people just won't use your stuff. So you need to be absolutely planning and communicating and not saying, sorry, that platform version's out of, it's going to be deprecated and you need to move to something completely different and inconsistent. I think that making people wait is it's really irritating. I think you should always think as a platform engineering team about how you can make it easy for people to get on with whatever task they're trying to carry out at the point they want to do it. It's about maintaining a loose coupling between teams and not slowing people down. So at the highest level, if you're a developer on a team and you want to do something, you should at least be able to find out whether there's something there that's already been created that solves that problem for you. Engineers can find out what exists. It's an astonishingly difficult problem for us at the FT, because along with all of our other autonomous decisions, pretty much every team had chosen a different way of documenting stuff. So if you wanted to know how to use a particular tool, you had to know which team had built it. So one of the first things I did when I took over the group was to put everything in one place as a starter, so you could find the information about how to do stuff. We created some marketing, we put posters up, we put stuff in Slack. We did a lot of work on documentation. We actually brought a tech writer in and trained the team on tech writing. Like, we did a workshop on that, because no one's really familiar with how to write effectively, but it made it much easier once everyone had done this course and we've created a template. So, we had some documentation. We started with, what is it? How can I use it? We had that template. It made it easier to write that sort of documentation. Self-service is kind of the core thing. You want people to be able to self-serve any tools that you have from a platform. So you don't have to support every use case, but you can just make sure that you look at the 80% of standard things people do and make it so that they can look at the documentation, get their own key without having to ask you for it, start to use that tool. And that is something that has often been difficult to persuade teams to do. The number of places I've been where you have to open a Jira ticket to have a key assigned to you. Teams at the Financial Times can self-serve DNS changes through infrastructure as code. And they open a PR in a GitHub repository. But actually the team went and spoke to their customers, and they went beyond that. And there's a really good blog post on the FT's blog about this. They found that most PRs got approved without any discussion. People fed back and said, sometimes it takes a day for you to approve this PR. But they looked and they analyzed a huge number of PRs, and they said, well, most of these are recognizably going to be approved. So they created a bot that would just automatically approve all those PRs. So now 80% of changes just get automatically approved. The next principle really is about making things easy to use. You should make it easy for people to get started using tooling. So a single on-ramp could provide API or GUI, sensible default configurations, and you shouldn't really surprise users. Like, people should get error messages if things aren't working. It's surprising how often people don't get an error that's helpful. We valued consistency. It's really much easier to start using something if it looks like something else you've used. So using the same names for the variables that you pass in, for example. Next principle is about allowing people to extend and adapt. This is about having a mindset that you are not the only people that can think of new ways of doing stuff. So you should allow people to do things you didn't expect. So we tried to build our tools to be independent and composable, which is kind of the Unix philosophy. So simple, short, clear, modular, extensible code that you can compose together however you like. One thing we did with this was people were starting to use serverless. We created a bunch of blueprints. So if you wanted to use a Lambda to read something off a queue and stick it into S3, you could just come to this repo and copy that blueprint, and you had that there. It's surprising how often that is a thing that people need to do. we tried to make things automation friendly, again, so that people could just call an API or use a CLI and do stuff. We wanted to help people to do the right thing. So you shouldn't have to read guardrails. It's surprising. There are very few developers who will go off and read pages and pages of guardrails. There are always some. Like the last time I gave this talk, I was like, yeah, me. I read everything. But not everyone does. And even if they do, they change. You're not going to go back and reread them every month or two to see what's changed. So actually what you ought to do is make it so you don't have to read guardrails. You just make it so things automatically comply with it. So we wanted every new system to be added to our system registry, which we call BizOps. And when you created a new system in BizOps, you would be generated a system code. And you would find it really hard to get into production without a system code, because you needed to tag AWS resources with a system code. You needed to put it into logs. And that just meant that we always got a record of systems before they made it into production. So you didn't have to understand that you needed to create a BizOps record. You had to do it just to make progress. Similarly with runbooks, we wanted people to create a runbook that would allow people to troubleshoot every system. Basic information about what can I do to fix any problems we have in production. So we did some scoring. We created a thing called the system operability score. We started scoring runbook fields, encouraging people, showing them which fields were important, what information we needed from them. And then we gamified it a bit. We grouped together all the services for a particular team. We showed people how they were doing. This was great because, first of all, we were an organization that used OKRs. So teams would use this score as an OKR because they can measure it. They say, we're going to improve our runbooks from 25% to 50%. And also, it led to a few Slack messages where people would send a message to me saying, hey, my team's overtaken yours. So it kind of, gamification works a bit, doesn't work for everyone. My team, within a day, had overtaken again on this. And we had one team that had no documentation and went to like 98% score within a month because they saw it as a challenge. You want things to be safe to use. So we would set defaults. We would look at a small blast radius. So you as a product engineering team member can effectively start using this thing without worrying that you're suddenly going to cost the company a lot of money or make it vulnerable to a security problem. And we made sure that things were secure and compliant. So it's safe for you to use any tooling that was built centrally at the FT. You couldn't go wrong with it. We thought a lot about reliability as well, because suitable levels of reliability are important. And suitable is about understanding what the different needs are. At the FT it's quite simple. We just went for 4 different levels: platinum, gold, silver, and bronze. Platinum systems would be supported 24/7 from the development team with a target to recover from failure in 15 minutes. These were generally the kind of systems where if this went wrong, it could be in the news. Like if the FT's website is down, that impacts the brand. Gold systems were business critical, so something like our customer care software. It's not going to be a news story, but it stops us from being able to do the key parts of the business. Bronze systems were things where we'd fix them during the day, and it really helped in discussions with stakeholders. They understood that building a platinum system was going to cost more because platinum systems had to be multi-region, for example, and developers knew that they only had to do hours support for things that were pretty resilient and were in multi-region, so you had failover as an option. So this worked quite well, and we didn't dig a lot into individual SLOs for different services. So those were the principles we had for building tools for the paved road, but we also needed to define what would happen when product engineering teams wanted to go off-road. So why would you do that? Well, you do it if the capability doesn't exist. And I originally thought about saying, and can't be created in time, but I've come to the conclusion that you should never trust a roadmap. So if a platform team says, oh yeah, we're doing that in Q3, they're probably not going to finish it in Q3. So generally it's like, if it doesn't exist, yes, you can go off-road, but there should be some kind of understanding of when it's going to be available. This is a lot harder to navigate if the capability doesn't meet the team's requirements. Because if you're a platform engineer and the product team go, yeah, I know you've got this thing, but I don't think it's very good, it's hard not to take that personally. So you have to really understand that, you can't necessarily meet everybody's needs. If you're building products for consumers, you know that your audience is not everybody, right? You focus on key audiences. And sometimes you get teams that are convinced their way is better, and sometimes they're right. So you really ought to let people try and be innovative. But you should have a plan for what this means, how you'll know whether it's successful. And we had a regular meeting at the FT called the Tech Governance Group, where we aimed to bring any kind of tech changes that had a wide impact. And the format was you circulated a proposal in advance. You actually went and spoke to everyone impacted before the meeting. So the meeting was really about communication. I think we had something like 99% of proposals got approved in the meeting. But that might have involved months of discussion beforehand. So I really liked that as an approach. So it looks something like this. It's 1 or 2 pages. It starts with what's the need. It looks at what you've considered. So if you wanted to go off-road, you might say, well, we need to do this, and this is why the existing thing doesn't work. This is based on, there's quite a lot of stuff online about like trying to do architecture decision records or requests for comments. It's a nice way, and then you have a record. So you can go back in 2 years' time and say, what were we thinking when we made that technical decision? That's surprisingly useful. So I really encourage doing something like this for technical decisions. Because you also need to make the plan for the long term. Let's say that a team develops this new way of doing something. Is it going to be adopted by the platform? Is everyone going to move to this thing, or is it going to be offered in parallel? Because the danger of a product engineering team going off and building a new way of doing stuff is when another product engineering team wants to use it. Because suddenly you're now a platform team as well, and that doesn't really work. Anything that's being built that goes off-road needs to comply with the guardrails. Otherwise, you are just opening yourself up. There's a lot of conversations I have had with engineers where they go, oh, we're just going to try this thing out. It's not going to take very long. It's still in production a year later, and it's not doing any logging, and it's not monitored, and no one's responding to security issues. That is a nightmare. You don't want to be in there. So I want to finish with an example of where having a paved road and a platform team really helped at the FT, and where this level of standardization and understanding our system worked. So I'm assuming that this audience is going to be familiar with Log4Shell. Yeah? Yeah. So security vulnerability in Log4j, allowing remote code execution. And there's actually a really great explanation in this blog about exactly what it looks like. Any of the user inputs on the left-hand side can be logged out and can be an exploit. And the vulnerability was discovered just before Christmas 2021. In fact, it was on my last day at the FT. And it was serious enough that this is bad news for me because I'm in charge of responding to incidents and I just want to leave. But anyway, it was serious enough that we needed to take action. But at the time of Log4j, there wasn't a lot of new code being written in Java at the FT, but there was a lot of Java about. There were lots of services from 5 or more years before that were running, probably hadn't been touched in quite a while. People who used any of the paved road capabilities got this patched for them very quickly, within a day. In fact, so quickly that we then had to patch everything again because they released another patch a day later. Other teams could use the tools we'd built as a central platform team to work out where they might be exposed. So we were able to find every repository that had code that depended on Log4j and be able to show teams whether they had to take action. So that paving the road and understanding your estate were really critical in responding to this. So I just want to wrap up. There's a tension between autonomy and standardization. Autonomy is great as an engineer, but autonomy is not the freedom to do anything you want. Autonomy is about being able to choose the way that you solve this business outcome. So if you're getting sidetracked from what you're doing for the business, you should think about whether that's actually where you should be focusing your time. You need to focus on the most important work, which is adding new features and new business value. It should also be the most interesting work. If you are someone in a product engineering team who's excited about like doing infrastructure-y and platform-y type things, you should look at platform engineering. It's a really interesting area to work, but you should be more focused on your business stakeholders. Organizations want developers to spend more time coding, less time thinking about and working on infrastructure. This is a really good summary of developer experience and why it matters that James Governor of RedMonk wrote. Companies like Monzo, Skyscanner, Spotify, they're successful with microservices, and it's based on a focus on developer experience and having those platform-enabling teams. And it isn't just about making sure that your team is effective. It's also about retention. Because why would you put up with a poor developer experience where you can go somewhere where it doesn't suck? So you want to be able to focus on making progress with business outcomes, not fighting your way through difficult processes to get your code out to production. So these are just a reminder of the principles that for doing something at the paved road. I actually looked at this when I was getting ready to do this talk and thought, it's actually not about platform engineering. These are good principles for building anything as an engineer. If you're building products, you should be thinking about what people need and making sure it's owned and supported for the long term, making things easy to use. But I think it really helps to have things like this in mind, because you look at your plan for the quarter and you can say, are we really tackling a problem people care about, or is it something we're most excited about? Have we tested that this is something people want to use? Have we listened to feedback from the last thing we built? Platform engineering, people often build a thing and they never go back and revisit it. You ought to be continually improving it. So that's it from me today. If that was interesting, I have a chapter about paving the road in the book that I'm writing at the moment called Enabling Microservice Success. It's out with O'Reilly early next year, but it's available on the early learning platform now. The first, I think, 9 or 10 chapters are up on that. And thank you. That's it from me.
The audio. Oh, thank you so much. Okay, thank you so much, Sarah. It's really a load of information. I really had a feeling, okay, I need to rewatch it through my app. And by the way, you can do this on your app. For all of you, it's available, the video recordings of all the sessions until the end of this week. And if you book the full week, so you're a full stack subscriber, you can do this for the next 6 months. Yeah, so many things to learn, and it's not only about tech, but really about handling all those issues in a world between standardization and autonomous. I really like it because I remember from the old world, we were speaking about process, and everybody had to feel now, oh, here's something to come which dominates me totally, right? And it's really about staying kind of fuzzy, can you say this? Yeah, because this allows to adapt locally, but on the other hand, of course, there must be a structure where everybody complies.
Yeah, yeah.
Thank you so much, and enjoy the day.
Yeah, if anyone's got any questions, please do approach me. I'm here all day. Thank you.